Kia ora koutou. Ngā mihi nui ki a koutou. No mai, haere mai ki te rangai pukaha. No reira, tēnā koutou. Welcome everybody to the College of Engineering, and thank you so much for coming to hear us today. I'm going to explain to you about studying engineering at the University of Canterbury, what sort of engineering we do, and why we think that we are the premier engineering college of New Zealand, and I'm going to explain to you the differences that we offer as well by coming here. So first of all, why would you want to study engineering? Well, in my view, this future is changing so rapidly. There are two things you can do. You can let it pass you by and wonder what happened, or you can be part of it. And that's where an engineer's career comes in. So we feel that we're educating engineers of the future. We're setting the trend and helping design that future instead of letting it happen to us. The other thing that engineers do is they solve big problems in society. They look at energy and technology and health and population. So if you want to be part of the world that's changing more rapidly than you can imagine, then engineering is the career for you. So what is engineering? Well, we think about responsibility and we think about sustainability. We think about complex problems. If you've come in from the airport today, for example, you'll have seen the new bridge, which is two white things that do this, if you've come in that way, or if you live around here, you'll know what I'm talking about. That's a massively complex problem, which has included several types of civil engineers, mechanical engineers, and electrical engineers to figure out how to get that bridge up. And they will have worked as part of a team. We want everything to be safe and secure, and we want, as engineers, to benefit society, change the world, and be part of the world's future. So, as engineers, we solve big problems. So how do we ensure that buildings and infrastructures are safe from natural disasters? How do we keep the power on? It's really important, especially in a country that relies so much on renewables like we do. How do we keep up with our increasing energy use as a planet? How do we harness renewable sources? We do pretty well in New Zealand. At certain times in New Zealand, 90% of our energy is renewable, but it's not 100%. And how can we improve telecommunication systems? Again, really important in places where disasters might happen. How do we manage our water resources? You're in Canterbury, water's a big issue in Canterbury. How do we ensure that dairy and forestry is sustainable and kind to the environment, and yet it's still things that we must do? And how do we improve the design of new medical technology? If you're a doctor, you're saving lives, but doctors don't do it alone. They do it with engineers and other people who are completely expert in other areas because they need equipment. And who designs the equipment? Engineers. So why would you come to the University of Canterbury to do your engineering? Well, we're in the top 1% of universities globally, according to the QS rankings in 2017. We're the oldest College of Engineering. We like to think of ourselves as the premier College of Engineering because we've been here since 1873, in Christchurch, first of all in the city and then out here. We've got actually now 3,400 students in the College of Engineering. We've recently had $144 million invested by the government in new buildings, and you will see many of those today if you go on a tour. Our degrees are professional degrees, so they are portable and transportable, accredited and recognised internationally. So what do we offer? We offer 9 disciplines. I'm quickly going to go through them, and then we've got some detail about each one. So civil engineering, which is very recognisable, bridges, buildings and roads. Natural resources engineering, using engineering to look after the resources of the planet, which could include, for instance, water resource engineering, again, big topic for New Zealand. Forest engineering, engineering and looking after forest management, very important for New Zealand. And chemical and process engineering, which has 2 minors. Mechanical engineering, which is a very, very vast indeed. Mechatronics Engineering, which at this university sits between the Electrical Engineering Department and the Mechanical Engineering Department. Electrical and Electronic Engineering with a minor in Power Engineering. We're very big on power engineering here. We have a very famous research centre for power engineering at the University of Canterbury. Computer Engineering, and you can do networking and communications. And finally, Software Engineering, which here is housed in the Department of Computer Science. So I'm going to spend a little bit longer on each one now. So civil engineering is really obvious. It's the design and management and construction of large facilities with bridges, buildings, roads and dams. So in the undergraduate curriculum, if you were to study here, you would look at structural engineering, which is really obvious, water engineering, geotechnical engineering, because what's going on in the ground underneath the buildings is just as important as on top. Transportation engineering, you've seen an example of that in the Volvo truck. Environmental engineering, engineering management and project management. These are professional degrees. You will be leading teams of engineers. You need to know about project management as well, and in fact people management. Natural resources engineering is designing technology for sustainable development, management and conservation of our natural resources, particularly relevant to countries like New Zealand. So we will look at things like water catchment in our degrees, environmental engineering, ecological engineering, again engineering management, same as the other degrees, natural resources engineering design studio, sustainable energy systems and engineering in developing communities. We do send a lot of our students overseas to developing communities to do engineering projects for their benefit. Forest engineering is a mixture of engineering and forestry and management. We're the only forest engineering school in Australasia. We do just about all of the research for the government because they haven't really got anywhere else to go. And we have lots of professors who are really, really well known in that area. So what would we look at in forest engineering? We'd look at roads, forestry equipment, because there's a big push for safety in forestry, harvest operations and management, transport logistics, the natural environment, obviously, and field trips to Canterbury's indigenous and exotic forests, it says here. We go other field trips as well to the North Island. There is a big overlap between forest engineering, civil engineering, and natural resources engineering. Chemical and process engineering is quite different. So this takes small-scale laboratory experiments and then turns them into commercial scale. So in other words, it's taking raw materials and turning them into processed and marketable materials. So a big one here would be the milk industry. So milk is a raw material, and the powder that New Zealand exports and relies on for its GDP is a processed and marketable material. But there are many, many other examples. So what would you do as an undergraduate there? You'd look at flow of fluids, heat and cooling, chemical and biochemical reactions, distillation, computer programs, and professional skills, as you would with the others. There's more chemistry in this one. You should be aware of that. Mechanical engineering is the design and development of everything you think of as a machine. Everything, from the tiniest robot to the biggest aeroplane. That's mechanical engineering. So if you're an undergraduate here, what you'd be studying would be manufacturing engineering, machine and product design, fluid mechanics and aerodynamics, thermodynamics and energy. Those are core courses. Material science, because you could be working with a range of materials as a mechanical engineer, solid mechanics, dynamics, innovation, product development, and again, engineering management. Just before we change, I'll come back to that car on the left in a minute, but that's the Shell Eco car, where we did really, really well in Singapore, and the students built that. So mechatronics engineering, moving on, is a discipline that sits between mechanical engineering and electrical engineering. Some people call it robotics, but most people are now calling it mechatronics. So it's the integration of electronics plus intelligent control in mechanical systems, which is where the two disciplines come together to design smart products. So you make a product in mechanical engineering, you understand how to control it from electronic or electrical engineering, and you bring the two together. Hence the traditional term robotics. So in that undergraduate curriculum, you would do mechanical engineering and some aspects of electrical engineering, but the special topics are engineering design, control theory, computer science, because there will be some programming in it, mathematics, sensor technology, and obviously we do deliver courses on actual robotics. Electrical and electronic engineering, we're starting to discuss this in the college at the moment, about how best to represent it. And we've decided it's the hidden engineering. It's the engineering that you can't see, and the reason you can't see it is because you can't see electrons moving around. But basically, if you didn't have electrical engineering or electronics, life would not be anything like we know it right now. So this involves the generation, storage, and use of electricity and the design of electronic and computer products. They're developing technological advances from personal computing and smartphones like this to the big vehicles. So the main themes in this curriculum would be circuits and signals, which is obviously a core subject, computer systems, digital electronics. Again, you see that management, engineering management come through. Embedded systems, robotics, because of the link with mechanical engineering. Signal processing, communication, control systems, absolutely essential for an electrical engineer. Power electronics, power engineering, and renewable energy system design. And I will just take a moment to say a little bit more about the research centre that's associated with this department. They're called the Electric Power Energy Centre, or we call them the Epicentre. They're totally funded by industry and the government, and currently at the moment they've got $7 million to look at smart grids in New Zealand, with particular reference to when people are putting solar panels on their houses, and if you can feed electricity back into the grid, what's it doing to the grid? Because we're generating our own electricity as a country anyway. So that is completely industry funded, and the undergraduates can get scholarships from that industry body as well. Computer engineering is electronics and software of embedded computers. So a bit like electrical and a bit like computer science, but joining the two together. So again, design and management, signals and controls, you've seen that in the electrical degree, networks and communications, but new would be graphics and HCI, human computer interface, that stands for, algorithms and machine learning, electronics and mathematics. And again, there would be some management in there as well. Software engineering is a degree we started about 3 or 4 years ago. It's been incredibly popular and doubled in size in student numbers within 2 years. It sits in the computer science department, but we have dedicated software engineering staff teaching those courses. So it's the design and creation of software for real-world constraints, so economic, ethical, technical, and legal constraints. So you would do the obvious programming, computer languages, comms, network, security, but you'd also do graphics, software engineering methodologies. There's a big emphasis on team working, web computing, information systems, and the bottom one, artificial intelligence, is run out of this degree. So just before we carry on, who's come down today from Auckland? Fair few of you. Your distribution company, Vector, is using artificial intelligence to look at the machines in your house and smooth out ripples in demand. That's a scary thought, but essential to keep the network going. Artificial intelligence is going to be absolutely everywhere in the future. Now, I'd like to come on to some points of difference about the University of Canterbury and engineering here. One of the things that we offer here is, as well as doing the Bachelor of Engineering Honours, at the same time, you can do a Diploma in Global Humanitarian Engineering. This is an extra diploma qualification that you get while studying the BE. It starts in your first professional year, so you enrol any time after you've completed the intermediate, which is our first year here. And it's open to all students in any engineering disciplines. What is it? Well, it's 45 points from the BE honours from any discipline, so you'll have done that anyway. It's 45 points of humanities and social sciences, and it's 30-point course or project. And we've just finished this year's course, and the students went into up north of Canterbury and spent some time away, and they had talks and visits from global humanitarian engineers about disaster situations, helping underprivileged societies, being flown in to fix something when there was an immense need. And then at the end of that project, they actually started to understand how to drill for water from nothing, having hardly anything, to help an imaginary village. In the years to come, we hope to be able to send those students over to places like Cambodia, because Australia runs what they call a design summit, and the students, as part of the Australian degrees, go over to countries like Cambodia and actually stay and work there for a couple of weeks and actually do real things, real projects, and improve the life of those villages or communities. So this is only 2 years old, coming up to 2 years old, this diploma. It's growing in popularity. It is extra work, not a lot of extra work, but some extra work. So we do put a GPA limit on it. We're hoping that more and more students will be interested in it because it's quite unique in New Zealand at the moment, and we're very proud of it. So when you graduate with your Bachelor of Engineering honours, you also graduate, if you finished, with another qualification, the Diploma in Global Humanitarian Engineering. That's going to do a lot for your CV. So why else should you come here? Well, I've mentioned this before. This is the Shell Eco car. The students built this up bottom up. They were helped by local industries, but they did all the design work and they did all the manufacture as well. So the local industries showed the students how to make the body work, but they didn't do it for them. They didn't paint it for them, they showed them how to do it. So this car went over to Singapore, sponsored by Shell, and took part in a competition where the idea of the competition is to use the least amount of energy possible going a certain speed round a track. And there's lots of other awards as well, design and that sort of thing. This is our first year ever in this competition, and we won the design award for this. We did have some technical problems on the end of the competition where we had to try and win the lowest energy prize, and we didn't manage that. But we're going to have another go, so we'll be back next year. This is a mechatronics laboratory, so on the left at the front you can see robots and students, and you can see robots with mechanical parts, but you can also see wires and things coming out of them. So this is the mechanical engineering plus the electrical engineering. This is an interesting competition. This is civil engineering first year. They have to do a project where they design a bridge to certain specifications. And the specification is it will take the weight of 2 people but not 3. And how are you going to test that? Well, you're going to erect it and 2 people are going to stand on it and then a 3rd person is going to get on it and it's going to break. And what more fun could that possibly be than doing it over water? So that's what we do. This is a field trip to a wind farm. So the point of this field trip, which would be for electrical engineers, is all about large structures, renewable energy generation, but also safety. So when you're generating electricity, it's very hazardous and you need to understand how to operate safely and work in teams. So what does our years look like? Well, we've gone into some detail in the first year here, but of course it's a very flexible first year, and that is quite deliberate. We have a flexible first year, so if you do not quite know what sort of engineering you want to do, anytime during that first year, you can change your mind. All you have to do is come and get some advice from the student advisors. So the first year, there are some courses you have to do. Not surprisingly, they're mostly maths. You've got to be a good mathematician to be an engineer. Also, we need physics for the basics, because what is engineering? Engineering takes physics, makes it applied, and turns it into problem solving. But then there are 4 other courses shown there, which you would choose based on what you think you might like to do, what type of engineering you might like to do in the second year. And then the next 3 lines we've left blank because I've already explained those to you, and they're quite different for each degree. Now, many people get through their first intermediate year still not quite knowing what they want to do, and there's enough flexibility in our first year for you to make the decision as late as November, December or January when you're coming back to enrol. We've done that quite deliberately. I need to talk about multiple entry pathways as well. So at minimum, you need 14 credits, maths, physics and chemistry for some types of engineering, but not all types, and you can get advice on that today. The maths must include differentiation and integration. If you have done maths that doesn't include those, we will offer catch-up courses which are before February, so over the summer. But the engineers need calculus. However, if you've got more than the minimum, we will be very pleased to start talking with you about a modified pathway into our honours degree. So if you've got 20 credits with 15 points at excellence, we will give you the opportunity not to do some of our first year courses and maybe to do some of our second year courses in the first year. Now, if you think back to what I said about before about the Diploma of Global Humanitarian Engineering, if you can arrange a modified pathway like that second point there, and you want to do our diploma, then you can do some of those diploma courses in your second and third year because you've already done the second year courses in the first year. Finally, if you've got very high marks, we do allow the top 5% of students direct entry into the first year of the specialisation. This means that you can get an accredited, fully transportable, professional Bachelor of Engineering honours in 3 years. That's pretty special. So just to finish off the discussion of the first year, we would like you to stay and do engineering, but if you decide it really isn't for you when you've done some engineering in the first year, there's other things you can do. The Bachelor of Product Design is a brand new degree for next year. You can do the BSc out of our first year if you wish, and you could do another degree as well, including Forestry Science, which is housed in this college. So what else about University of Canterbury should you know? Well, I mentioned before we've got this huge investment in new facilities. So the picture there is the Structural Engineering Lab. It's the biggest one in New Zealand. The walls that you can see at the back of the picture are reinforced with 65 kilometres of steel, which is pretty special. That building's won awards throughout New Zealand for its design and functionality. And what you can see there is some crane type apparatus. We tie buildings onto it and then we shake them and we measure how they would respond in simulated earthquakes. Also, we've got wings in all the other types of engineering as well. All our buildings are re-engineered to top of the range New Zealand earthquake engineering standards. All our buildings are also low rise. All our laboratory wings are low rise, 1 or possibly 2 stories. If you come next year, you will be the first students to use all of our new buildings. We can't wait for them to be opened. So just some pictures. There's the core, that's the student area where the lecture theatres are. That's a computer laboratory there, very light and airy. That's the structural engineering lab that I told you about before. This is chemical and process engineering, deliberately designed to look like an industrial laboratory so that when you're studying, you don't get a nasty shock when you go to work and the premises looks different. We've simulated what actually happens. That's what the mechanical engineering wing looks like from the outside, not quite finished inside, unfortunately, but finished by the end of the year. And that's one of our other wings. So they're all designed to look and feel like what we're calling the engineering precinct. Lots of student clubs at university. This university's got more student clubs than any other university. We've got several of them in engineering. The very famous NSOC is there. Engineers Without Borders is also very famous. Women in Engineering, and Computer Societies, CompSoc and WITSOC. All those societies also organise tutoring and mentoring help for new students. That's not widely known. That's a really fabulous piece of work they do to support the university. We're also unique here in the Engineering College that when you join us, you'll be allocated your own academic. So you'll be in a small group with other first-year students, and you'll meet regularly with an academic who will just talk to you about university life, how to settle in, answer any questions. And I myself have a group, and we're discussing ethics from an engineering point of view the next time we meet, and they seem really excited about that. So that's something we promise our first years, and as far as I'm aware, that's not happening anywhere else. And there's many sources of help, just ask. The university's also got a centre for entrepreneurship. Engineering students really like this. It's a dedicated space with BCom students. So if you've got a fancy idea and you don't know how to take it to market, you would go to the Centre for Entrepreneurship and get some really good tips. And we've got an incubator program as well. We like students who want to start their own companies. There's lots of support for that. In the final year, we have very, very close connections with industry. In every department, the final year projects are sponsored by industry. They pay the university for students to solve a problem. The upside for the students is that you get to work on a real problem that industry needs, and you may even land a job with that industry when you've finished, because they've got to know you because you've worked on their project. We also want students to go out into the community and do practical work, which is 100 days or 800 hours, and we can give you more information about that later today if you're interested. Finally, we offer exchanges with universities around the world, including Berkeley and several very high-class universities in the UK and Europe. Civil engineering students in particular seem to really like doing that, but we offer it across all the engineering disciplines as well. We have a very good scheme here at the university called the Erskine Scheme, where we will pay for visiting professors to come and teach you. And we make sure they're from places like Oxford, Cambridge, Harvard, MIT. That's a unique bequest to this university. So we always fill those places because we pay them to come here. And who would not want to come and work in New Zealand for 3 months and get everything paid for? So you can learn from the world's foremost experts, and we get about 50 of them a year coming. Scholarships, this is on the scholarships page of the website. We have specific ones for engineering. We've got 10 top scholars, 30 high achievers, MARI, power engineering scholarships I mentioned before, and international scholarships as well. The good thing is that most of these you can hold at the same time as other university scholarships as well. So you could build up a personal portfolio of scholarships that actually really contributed to your financial welfare when you're here.